This lesson is going to look at another type of transformation, which is called a rotation. A rotation is the transformation in which a figure is turned about a fixed point. So the non-mathematical name for a rotation is a spin or a turn. In terms of rotations, they're usually described in degrees. So if we look at your coordinate plane or the graph, this is your y-axis, this is your x-axis. It's divided into 4 equal parts. And those two lines are perpendicular to each other because they form 90-degree angles. So there should be 90 degrees in each of the 4 quadrants. So if it goes 1 quadrant, that's 90 degrees. 2 quadrants, that's 290 degrees or 180 degrees. 3 quadrants, or 3 times, that gives me 270 degrees. And then if it goes all the way back to the beginning to where it started from 4 quadrants, it turns 360 degrees, which is the degrees of a complete circle. The other way in which a rotation is described is whether it goes clockwise. Clockwise goes the way a clock goes in a circle like this, and counterclockwise goes the opposite way of the numbers on a clock. So if you're looking at this particular running guy, he starts up here where the yellow dot is, and then he's rotating clockwise, so he's rotating this way, right? And then the first box would be a 90-degree rotation. If he goes 2 boxes or 2 quadrants, it'd be a 180-degree rotation. And notice he's rotating. He's rotating around a fixed point, or turning about a fixed point, which is that point in the center, the origin. So he's going directly in a complete circle. The last thing I want to take a look at in this video is a line of symmetry. This goes back to an elementary school concept. A line of symmetry is a line that divides a figure into 2 parts that are reflections of each other, or basically that are exactly the same. So let's take a look at a couple of figures and find out how many lines of symmetry each one has. So if we're looking at this first one line of symmetry could be this line going horizontally across the middle, because if I folded that line there, both parts would match up. Now that figure does not have another line of symmetry. Then let's look at the triangle across from it. Looks like an equilateral triangle. So that equilateral triangle, if I divide it here, both sides would be the same. And then if I did the same thing from each other corner, both sides would be the same with the figure. Then I want to take a look at the rectangle. The rectangle would have a line of symmetry vertically, because if I were to fold that, both sides would be the same. And it would also have one horizontally, because if I were to fold that, both lines would be the same. However, I cannot connect them diagonally because both sides would not be the same. And then if I'm looking at the arrow would have one line of symmetry down the middle. And then the same thing with the smiley face, because the smiley face has the eyes and the mouth. I cannot go horizontally across the middle, because then the eyes and the mouth would be in the same position, and that wouldn't match up because they're not exactly the same body part, right? So lines of symmetry, the best way to test it would be to see if you could take that figure and you could fold it to match each piece up. If it folds correctly and it matches side to side, exactly the same size, then it is considered a line of symmetry.